Okay, so I'm going to take this up because we don't have a lot of time. And there's another concept of just even looking at the quick results of the quiz. Either most of you got it, most of you don't, so it's a good chance to review. I know it's been a long time since we had the last class. Hopefully you did your homework. I'll get it on later on, check if you did or not, but I can see who kind of did already on the quiz, right? I mean, we did two main concepts before this: midpoint, length of the line. So we did a little bit of review, equation of a line, good grade 9. So just before we talk about doing this question, what classification of a triangle? So if you don't remember, write this down. So scalene triangle again was all sides for different lengths. All sides are different lengths. Isosceles, two side lengths, the same length. Finally, equilateral, all sides are the same length. With this unit, I highly recommend, because it is geometry, we can actually see things and sort of dissect the problem a lot better if we get a visual. Okay, even this problem that may be as simple as this, let's just draw it out. So if a triangle vertices -3, 1, so it's right here. B is 1, -3. There. And C is 3, 1. So we have a triangle. Okay. So since we're just dealing with side lengths, talking about classification of side lengths, it's just our length formula. So I'll just label my triangle like we normally do from trigonometry, A, B, C. So let's do A first. So A is the square root . Okay, so that's our length formula. So basically for A, we're looking at these coordinates. So let's remember, when we're doing length, we want the distance between the 2 points. So we need to subtract our coordinates. So here x2, so I'll do 1 minus 3 quantity squared plus -3 minus 1 quantity squared. So we get -2 squared plus -4 squared, which gives me 4 plus 16, which is the square root of 20. Okay? Yes. If you're going to leave your answer as radical, it'd be nice. I'm not going to make a requirement, but once you get into grade 11, you'll be working a lot more radicals, and do expect you to simplify them. So this works out to be same thing as 4 times 5, square root 4 times 5, which gives me the same thing as 4 times root 5, which gives me the final answer 2 root 5. Okay, so again, that was a review of how we simplify a radical.
So, like for future, you want us to make it?
Yes. Right. Leave it as the exact answer.
On the quiz, we just said
Square root 20, yes.
Okay.
But then if you leave it as radical, try to simplify it to 2 root 5. So b is equal to square root. You good with this? I don't need to do this. Go straight to the lesson. So we got -3 squared plus -1 minus 1 squared. So b is equal to, so -3 minus 3 gives me -6 squared plus -2 squared. So b is equal to 36 plus 4, which is the square root of 40, which is the same as 2 root 10. Okay. So we can already see that we have two side lengths that are different. Can we immediately classify a triangle? Well, we can only rule out one thing. It's not an equilateral, right? So we still need that third side to either say it's either scalene or isosceles. So we'll do C. So the idea of doing these questions, if after you do a couple of these, if you cannot memorize the length formula, then we need to work on our something else, right? Yeah, so we do a plus, we mess it up, so that's what we get to practice, right? You write this equation all enough, you're gonna remember it. So here we get square root of, so C, we're looking at -1 minus 3 quantity squared plus -1 minus the -3 squared, right? So we need to take care of their negative signs. So I purposely chose points in our triangle that had a lot of negative signs. So this last one's tricky. -1 minus the -3. So we get square root of -4 squared plus 2 squared, which gives me the square root of 16 plus 4. And again, that's root 20, same as 2 root 5. So we can see that A and C are the same. So therefore, since A is equal to C, it is an isosceles triangle. Okay. Difficult question in terms of its lengthy. Do we need a calculator to do a lot of these numbers? No. Right? So we need to be clean with arithmetic. How would I go proving that this is a right angle triangle? How would I go verifying that this is a right angle triangle? Alex?
Maybe by using slope.
How would slope help us?
Well, if one slope is a negative, the other it's perpendicular bisecting.
Well, so that's just a perpendicular. You have perpendicular lines, or perpendicular slopes, right? Negative reciprocals. So if we calculate two slopes of our 3 lines of a triangle, if any two are negative reciprocals of one another, they're at 90 degrees, right? So that was another concept that we needed from grade 9, needed very forefront in this unit. This idea of negative reciprocal is 90-degree angles of our lines. The nice thing about this is how many slopes do I actually need to calculate to determine this is a right angle triangle? What's the bare minimum? You need at least 2, right? Because they have to be negative reciprocal of one another. Do I need the slope of all 3? Can there be 2 90-degree angles in the triangle? There cannot be 2 right angles in the triangle, right? There can only be 1 right angle. There? And we'll get to that too. Okay? So the nice thing about the visual is I could almost kind of see in our diagram, even though it's not completely accurate, that this is my 90-degree angle. So I'll do my calculations based on that. So I need the slope of AB. So the slope, remember our notation, slope of AB is delta y over delta x. So in this case, I have -1 minus a -3 over -3 minus 1. That gives me 2 over -4. Give me -0.5. And look at that line, it's going downwards. Seems like I got my sign right. It's -0.5. So So the slope of BC is equal to delta y over delta x all over, so I get -4 over -2, and that slope is 2. Are those negative reciprocals of one another? Pardon?
That's how you talk it.
Well, we take one of them, so let's take -1/2. What's the opposite sign to that? Then it's just a half. You take what it signs a half, and what's the reciprocal of a half? 2. So therefore, since slope of AB is perpendicular to slope BC, it is a right triangle. Okay, so that's how we can use slopes and just proving shapes. So Eric mentioned another way we could do it.
You can use the 2 points and use a squared plus b squared, and if it equals the other point, then you know that it's the right triangle.
Yeah, so we recognize that in the right triangle, we can apply the Pythagorean theorem. So if the Pythagorean theorem proves true, automatically we know there's a right angle in there. So our equation for that is a squared plus b squared is equal to c squared. Well, how do we know which is which? Or should we do it this way?
Just find the length of the side so you know which is the longest, doesn't it?
So this is the left-hand side, right-hand side. So this is c squared. So we just want to see if those two sides of our equation, we need to verify they come with the same number. But how do we know which side is which? Which is A, which is B, which is C? How can we say which is A, which is B, which is C? Yeah, C is the longest one. In this case, which one is that? Square root of 40? Right? Does it matter which A and B, which is A and which is B afterwards? No, it doesn't matter. So we have the square root of 40 squared. A was, one side was square root of 20. What is the other side? Same. So what's the square root of 20 squared? What's the square root of 20 squared? Square root of 20 squared. Plus 20. I know we're doing really highly complex math here.
Too early, Mr. Chan.
Square root of 40 squared. 40.
Oh.
So here the Pythagorean theorem holds true. So this is another way you can show me that yes, there's a right angle triangle in there. Okay, so you have a therefore statement. Therefore, since Pythagorean theorem holds true, it must be a right triangle. He said it's the longest question ever, he ain't seen nothing yet.
Well, I mean, for grade 10. I know
Couple
in
weeks.
I know in university.
So I have 30 minutes to do this next example with you guys.
30.
Yes.
It's gonna take the whole time for one example.
So take out your notebooks. It's going to be a very important example we're stepping through. Let's go, please.
Oh my gosh, you're examining exactly one.
So the and we're gonna actually use as an example, is the shortest distance from a point. So in this case, we'll go point, this red dot out here, to a line. So we want the shortest distance from a point to a line is the line segment that is perpendicular to that line from that point. I know it's a mouthful, so write it down and I'll explain it more in detail with an example. So the shortest distance from a point to a line is the line segment that is perpendicular. That concept again, perpendicular to the line from that point. So draw this little example that I have, a line and a point. Okay, so what we're saying is that if we can draw a line from the red dot to the blue line that crosses at a 90-degree angle. So I'll try my best. So let's say like that. If we can make this a right angle here, okay, that is the shortest distance. That is from this point on a blue line to a red dot, whatever this length is, L, this is the shortest distance. Okay, so I'm going to take 2 minutes to kind of explain why. I mean, there's one concept that you guys learned a long time ago, I don't even know what grade. What's the shortest distance between 2 points? Shortest distance between 2 points. A line, right? A straight line, right? So that's sort of how we calculate. If I want to go from point A to point B, what's the fastest way to get there? Shortest way to get there? To a straight line, this is the shortest way. So there's almost an extension to that is what's the shortest distance from a given point to now a line. So any point on our line, we want that shortest distance. Why does that make sense? I think intuitively look at it, it might make sense. Well, let's kind of prove it. Let's just say that that is not the shortest distance. Okay? This point here, P, is not. Let's say we have a point Q. Any other point, Q, that is the shortest distance. Okay? So if I draw a line from a point to point Q, what is it that I get?
Oh, it's not the shortest distance.
What is it that I get though? We get a triangle, we get a right angle triangle. Right? So this is a right triangle. Well, what is it that we know for sure, factually, about right angle triangle? Which is the longest side? The hypotenuse. So in this one, which is the hypotenuse? Yeah, so right here, this is our hypotenuse. So what we know factually for sure was saying that, well, H has to be longer than L. But we just said that L was not the shortest side. So what we did is we proved a contradiction. Okay, it's a very popular way in math and other fields of science where we prove something by assuming the opposite, and then we demonstrate by following through certain principles that we get to a principle that is absolutely wrong. And that, if it's absolutely wrong, that means your initial assumption has to be wrong. Okay, it's kind of cool. You get to hopefully later on. Did lots of it in university in computer science. It's really cool, right? So basically, we assumed that L was not the shortest side, came up with something that was absolutely false. So therefore, L has to be the shortest side. Okay. We made an assumption that L was the shortest side, but based on that, we came up with something else where we disproved or was contradicting L being shorter than H. So therefore, initial assumption has to be false.
Wait, so screen and not proven according to Guam.
No, L is the shortest line.
Is it PQ the shortest line?
No.
What?
Shortest line from the red dot to the line.
Oh, okay, from the red dot.
From the red dot to the line.
Oh.
So you may think like, okay, that's cool, who cares, okay? This actually has lots of practical examples, just like when we did the shortest distance 2 points. This blue line, this could be a road, right? So we said this is a road that's out in the country. I built this cottage over here. And because it's out in the boonies, I have to park my car somewhere along this blue road and hike a considerable distance to get to my cottage. Well, my kids have been working hard all summer now, and they want to build this road. So, Dad, we're gonna, with our summer savings, we're gonna help you build a road. Well, you know what? Roads are expensive. You know what? We want to do this. Okay, fine. But you know what? I love my kids. I only don't want to work that hard. So I says, well, what is the shortest distance from this cottage to the road? Because if I get that shortest distance, I build the shortest road. So if it costs me, let's say, $1,000 for every meter to build a road, right? Every meter that I can get it shorter by saves me $1,000, right? So if I could get that shortest distance, beauty. So I can calculate what that length is, and then I can say, you know what? You guys don't have to save $100,000 for the next few summers. Earn that much to build that road, right? Because it's going to be a kilometer. So now we're just going to go through an example of actually how to calculate this. So calculate the shortest distance, and this was actually the last question on that first handout I gave you guys. No, second handout. When you guys did the Smarties example, I said there's one last question you guys couldn't do yet. Well, this is it. Working hard, earning money to build my road.
Where's the road?
Okay, write this example down. Calculate the shortest distance between point A, which is 6, 5, and the line y is equal to, 2x minus y plus 3 is equal to 0. So I sort of drew it out already. So the blue line is our line. That is 2x minus y plus 3. And then we have our point 6, 5. So once I have this visual, I want the shortest distance from this point to the blue line. That's what I want. So to help us step through in solving this problem, what 3 things do we need to find? Well, how does that help us though? Is this ready? Sorry, Zach, what'd you say? Yeah, we need a point. In order to calculate length, what do we need? We need 2 points, right? We're only given 1. Right? So we need another point. Unfortunately, that's the last thing we need to do on here. So we need a line point on the line. Sorry? Somebody said something?
We need the slope of the blue line.
Why do we need the slope of the blue line?
Find the slope of the right dot where it connects.
Yeah. So we need the slope. The first thing we really need is basing what Sabrina's saying. We need the slope of the blue line, or of the line. That came up ugly. And why is it that we need the slope of this blue line here?
Find the perpendicular negative thing. So it connects to the green line.
Yeah, so we need to find the perpendicular slope. And why is it that we want the perpendicular slope? Why was that important?
Find the short side.
Yeah, right. We just learned that if we find a line that's perpendicular to that passes through a red dot, that gives us the shortest distance. It has to be at a 90-degree angle. Well, what's the second thing that we need then? Well, that's our final thing. That's really the end. So I'm saying we need three things before we can actually find the length. We need another point on the green line. Well, sort of.
No, we need. Oh.
Tyler?
We need to find the slope of the green line.
Well, we have the slope of the green line.
Oh.
Y-intercept of the perpendicular.
The y-intercept of the perpendicular, the green line?
Yeah.
You're kind of close. We need the equation, right? So we need the equation of the perpendicular line to the point. Why is it that we need it? No, we said, somebody said slope, somebody said the y-intercept, but why is it that we actually need the full equation? Why is it that we need the full equation?
Well, because there's an infinite amount of points on this line.
Yeah, but what helps us with the full equation though? Tyler?
Use POI to find the point.
Yeah. What really is this point, this blue point here? Right? This really is a point of intersection. Because if I extend this green line, what do we have? We have two equations, two lines. So we're just finding where they intersect. Okay, so that's how we actually find point 3. So let's work on the first one. How can we get the slope of that line?
Wait, we're finding the slope of the green line?
Well, first we need to find the slope of the line,
Which line? Oh, yeah, okay.
right? Because finding that slope would help us find the slope of the perpendicular. That's the only way, right? Because we don't know we don't know 2 points, right? We only know one, but we could get the slope indirectly, so to speak. So how can we get the slope of this blue line?
You just move y to the other side and make y equals 2x plus 3.
Okay? So we're gonna isolate for y.
Add y.
Yeah, we're gonna isolate for y. So we get to y equals mx plus b form. So in this case, Nick is saying that we add y to both sides. Okay, so we add y to both sides. We don't move things. We add y to both sides. So on the left side, we're left with 2x plus 3, and that's equal to y. So what's the slope here? So what's the slope of our blue line? 2, right? Y equals mx plus b. Wherever the coefficient to x is, that's our slope. So here. So therefore, what's the slope of the perpendicular line? Yeah, negative reciprocal, right? So it's equal to negative the reciprocal of 2. 2 is just 2 over 1. So there's a slope of the perpendicular line, negative 1/2. And again, if we have that visual, we can kind of see it. At least we got the sign right. It's negative. It seems somewhat flat. Half is pretty flat. So we kind of know we're on the right track. How do we get number 2 now? How do we get the equation of this line? So how can we get the equation of the perpendicular lines? So how can we get this equation now? It's on fire.
I am actually done.
How can we get the equation of the perpendicular line? Grade 9 question, quite honestly. Except it's not really spelled out for you. We have to do some work there. Alex.
Well, we plug in the slope into the equation y equals mx plus b.
Okay, so we start with y equals mx plus b. So now that we know the slope, right? So now that we know the slope, and negative 1/2 x plus b. What else?
Then we plug in the point that we already have, which is red dot.
Yeah, We need a point that's gonna pass through this line, right? Well, does the red dot gonna pass through the green line? Well, yes, because that's what we're looking for, right? So it has to. Questioner?
That slope, the 2x plus 3 is y, which line is that?
That's for the blue line. Okay. So what we're saying here is when x is 6, y is 5. So that's how we solve for b. So I get 5 is equal to negative 3 plus b. Add 3 to both sides. And I get b is equal to 8. So therefore the equation of perpendicular line is y is equal to negative 1/2 x plus 8. Okay, so a little bit of work just to get through those two parts. Was it difficult work? I hope not. I mean, question number 2 should have been straight out of almost a grade 9 exam, right? Equation of a line given your slope and a point. How do we get that equation? You have a question there? Or I thought it was up there.
So that one is the green slope.
So this one's the green line. Yes, I should have done it in green marker. So that's your green line. Okay, that's what we just have to solve. Finally, how do we get that point of intersection?
Do a line equal each other.
Y equals each other? Y equals each other. Do you remember what method that was called? Not quite.
I usually do elimination.
You usually do elimination. That was one way. What does elimination do?
I prefer my elimination.
I like the comparative.
So your method, Sabrina, was called a substitution, right? We'll do any choice, put it to a vote.
Elimination.
Elimination is, I think, a lot harder for us to visualize, so do that. So what's the equation of the first line again? Y is equal to 2x plus 3? And the second equation is y is equal to negative 1/2 x plus 8. So again, we have our two equations. How do we eliminate? Well, we can see that we eliminate just by subtracting the two, right? Y minus y will give us 0, so we can subtract. So we get 0 is equal to 2 minus 1/2 x squared. 2 minus 1/2 x, sorry, 2x minus 1/2 x gives us 5 over 2x, right? It's actually 2 plus 1/2 x. 3 minus 8 gives us negative 5. Right? So again, so this brings us back to that first unit, right? So we're doing a little bit of review already on solving for linear equations. Come full circle, so to speak, right? So you guys did get that one. So 5 is equal to 5. Add 5 to both sides, so 5 is equal to 5/2 x. Multiply by 2/5, because I want to isolate for x. So some of you may not be aware of this trick or forgotten this trick. We have a fraction as a coefficient to x. Just multiply by the reciprocal. If you take any fraction, multiply the reciprocal, you're always going to get 1. So we do that, we do the other side. X is equal to 2. Done? Well, you could do it the longer way. Right? Multiply both sides by 2 and then divide by 5. Same thing. So how do I get y? Yeah, just plug x into one of my equations. So you're going to pick this first one, because I don't like fractions. So y is equal to 2 times 2 plus 3. So y is equal to 4 plus 3. Y is equal to 7. So therefore the point on the line closest to the point 6,5 is 2,7.
Where's that first word then?
Therefore, the point. Woo!
Sweating a little bit.
Yeah, it's hot in here. Who says math is not a workout?
Never hot in here. It's always freezing in here.
So we're done? Yeah. So we're not done. We haven't even answered the question yet. But you know what? Honestly, when we got to this point, figuring out the other point, right? 3 long steps to get there. So let's just finish it off. It's like we're in the last 100 meters of the marathon, right? Equation. We did 3 examples of this already. Therefore, L is equal to square root x2 minus x1 squared. So there I got 6 minus 2 squared plus 5 minus 7 quantity squared. So I'm left with 4 squared plus negative 2 squared. Left with 16 plus 4. Well, look at that. That's root of that.
Would this question be worth like 20 marks?
Yeah, how many words would this be?
That's
And the crazy part is
That's
six.
the part that
Which is 2 root 5.
You hate to simplify it.
It would be nice if you did. Okay? Again, that happens.
Alright.
So, a couple of questions were asked this way. How much is this worth on a test? 4 to 5 marks.
What?
Well, 1 mark.
I'm gonna lose technical marks.
There's no word problem.
Think about all the steps that we need to get there. 1, 2, 3. Each of that could have been a mark.
need to find.
And then finally, we got our final answer. So at least 4 marks,
So who cares what the word?
if not 5. One of those steps may be finding that. The second one, I don't know, finding equation line should be pretty easy for you guys. That shouldn't be worth a mark. 2 marks in grade 9, 1 mark in grade 10, right? So the point was that, what happens if I messed up in the beginning? If I got that slope wrong?
And it's all closed.
This is why, especially in this unit, because when we go solve the final answer, lots of steps in between, we need to take care of our arithmetic. The biggest thing, taking care of our signs, right? The math in there wasn't hard, right? Negative 3 minus 1 is not hard. But it is when all of a sudden we get negative 3 minus 1 gives us negative 2. And that messes up our calculation of everything else. Okay, so we need to absolutely take care. So as you do your homework, go through it, check your answers in the back, right? To expose the silly mistakes that you're making so that you can correct them. Be aware of them and making sure they don't happen again. Somebody had a question here? Nick? You might. Okay. It's not a no.
That face looks like it's a yes.
It's not a no. It's that interesting because whenever my kids ask me
I'd
stuff,
rather have a quiz on this.
I either say maybe or we'll see. And somehow they figure out that one of them meant yes and one of them meant no. And I think it's we'll see means no and maybe means yes.
True. What did you say this time? Yes. Maybe it was yes, right? Oh, right.
Any questions on this example? Okay. It wasn't anything new per se. The only new thing was that beginning concept. But everything we applied, we've learned already, right? Negative reciprocals, length of a line, point of intersection. Okay, for homework,